In this video, I'm going to demonstrate R programming language, and I'm going to have an introduction to programming language named R language. So let's discuss that one. And this video is going to be posted at youtube.com, and my channel name is MyWebUniversity. And the URL that you're seeing here, youtube.com/@MyWebUniversity, is the name of the channel or the channel handle. You're welcome to watch these videos and learn from it. I hope I can make a change in your life and your career skills and your school classes that you're taking, so you can just do better at everything that you are doing it currently. So let's get started with this one, and then we're going to show you the software installation, which is the URL for the software installation is a secure page. It's r-project.org, which is https://r-projects.org is the website. So, and there's also a CRAN, which is comprehensive R archive network. This list of all the packages, and including the software for R console and R studio, is provided on this r-project.org. You're welcome to download it and install it for your operating system, whether you're using Windows, Mac, OS X, or Linux. There's a lot of different operating systems are supported in R, which is a very nice programming language for statistical and automations of generating graphic images. And I'm going to explain each one of them one by one. So all the features of R, let's get started with that. First of all, R is open source, which means GNU.org or GNU. GNU stands for GNU is not Unix, which is a recursive call itself. And R is also supported like less programming language, that is nested recursive calls, function calls that you can do it with vector and other kind of mathematical formulas. You can do nested function calls. Lisp is one of them. So GNU itself, the name was GNU is not Unix. From day one, it was written in C. All the utility of GNU, including R language, which is open source, is published under General Public License, JPL. And GPL, not JPL. GPL and General Public License, and it is free kind of software that you can download it. And as long as you maintain the software, if you have to enhance some packages and make your own modification, customize some of the packages your way, and you distribute it to the developers community, to the public, and then you maintain the general public licensing of freeware, you can do so. That's what open source or free general public license GNU stands for. So make sure that if you are just supporting that one, it is all the time free. You don't have to be a student to just get a free version. Everybody gets a free version, which is nice. So R is an open source, and then R is inspired by S language. S stands for statistical programming. S was back in 1972, I believe. There was developers that were working for Bell Laboratory at AT&T. Bell Laboratory that they come up with a statistical software called it S language. S was one of the predecessor of R language. So R is the successor for S language, which is supports the statistical packages and a lot of other kind of computation and what data analysis, data mining, data science, kind of graphic data visualization, everything R supports. But R was inspired by S language, which was a statistical software. And R is stand for R language is actually the two pioneer was Ross and Robert, the two of them that built R. They came out with the name R, which was a success for S language as well. And then R is a programming language for statistical computing. It supports all statistic and probability data kind of analysis you can do with R. And then I'm going to provide this one at my YouTube channel. So in addition to knowing that it's an open source and it is statistical software, and also it's the language of data science, basically, you can know that our language is a language of data science, which all the data scientists are using it extensively. And as a matter of fact, R was one of the languages that is #1 for data science users and data scientists. So data science is part of like R is part of data science nowadays. You can say that it is, if you are a data scientist, you must know R. And if you know R, you can do good at data science and data visualization, as well as data modeling, data mining, and data analysis, which is also in the field of bioinformatics. It is some of the students that they are going for bioinformatics for their master's degree, they could do data science with R, MATLAB, and a lot of programming languages that are for statistical and data visualization and data mining and data analysis. You could do that one, and then R is great for that purpose as well. And R is like similar to Python. Python is #2 maybe, or R is #1 on the data science at ranking at this time. But yes, Python is supported a lot of the nice features. The good news is that both Python and then R language and a lot of other languages are written in C, including C++. So the C language was used, C and Fortran, and then R itself to build R language. And R is an interpreted language, it's not a compiled language. And then R with interpreted language is still, because it is used for C programming language, as well as functional programming, as well as object-oriented programming, as well as R supports for all this statistical data visualization, graphic, and imaging. It is really the language of choice that you can just do with it. Whether you use the R command line, which is in the console, console, or you do the R Studio, which is in the integrated development environment of it. R Studio is the graphic or GUI, graphical user interface. So if you're not familiar with the IDE, integrated development environment, when you use R Studio, everything is on the development environment. They're integrated. So you have a console window, you have a terminal window, you have a lot of panes and that you can use. Each pane, you can get help on it, you can graph it, and you can do visualization, you can do Excel data analysis, you can look at different panes, and I will show you those ones. You can see that one. R Studio is integrated development environment, which means it has the source and it has the console, and you can write the live script with R Studio. Everything is available for you. You're going to enjoy it as a data scientist, as a bioinformatics, data modeling or data mining. In fact, for the part of data mining, Oracle and IBM use R language for data mining to integrate a lot of products with this, and they use the commercial part of it there. Even though R is open source, some companies like Oracle and IBM, they do use R language for commercial purpose using data mining and big data. Big data and data mining is a concept that you're working with really huge data size. And when you're data mining and data analysis, you're working on big data to collect certain data sets. And then from that data set, you could get data frames, and you could get the tables and other ones, and you just generate those information in terms of objects and classes that you can manipulate it, because R supports functional programming as well as object-oriented programming. So we were right here when I just went back to the other slideshow. So let me just talk about R supports 6 type of data structure. So the data structure that R supports are vectors, as you can see here, the list. List is another one, matrix is another one, arrays, factor, and data frame. In the later videos, I'm going to demonstrate each one of these data structures. As a computer science student, we learn a lot of them, and every programming language supports it. The one thing that you should know in R, and also using R language and also MATLAB, the array and the matrix and vectors, when they start, they don't have an index of 0. The index starts with 1, because that's how math computation of these linear functions, calls, and vectors and computation that you're happening, you're not going to have an index of 0. It does not mean anything in math. So as a result, when R is doing the statistical probability and all these sequence, and then you just are looking at index, you're looking at index 1 for the first one, and then index 2 for the second one, and so on. The same thing for the vector, same thing array for matrix, and everything else like factors and list, and then data frames. The reason you have all these 6 data types is for different purpose, and for performance reasons, you just do these, all of these ones. And then all of these functionality that are supported is part of the base packages. So these comes in, but when you use a data set or using a data set that you're installing a package that are to extend our language for functionality and different data structure or data frames. Data frame, we call it, and data frames are rows and columns, two-dimensional arrays, or two-dimensional or tables of objects that you can manipulate and then get some data and plot them and delete the record, update the record, and manipulate it, print it, plot it, whatever you are doing it. Those ones are part of the extended libraries that are going to be added, and R supports a lot of the libraries out of the box. And then that's called base libraries. And then you have other extended libraries. Tidyverse is one of the very big packages that R supports it, and then I'll show you that one as well. So R is functional programming, meaning that you can write a function, you can declare a function. A lot of the math function, a lot of the probability and the statistical function is already part of the base function. You don't have to rewrite a sum or a product or a vector or a sequence or range or other ones, but a floor or a ceiling, all of those ones are absolute value, mean, median, all of those ones are part of the base functional programming that support the out of the box R. When you just install R, you start R, those functions are available, and usually you could load the base library. Then you could just say library and then base, and then you just get access to them. The reason you load them is because R wants to just save memory, and so out of the box, it just comes out with a lot of the functions that are needed, and a lot of the of if statement, for statement, a lot of the looping and everything that you need to do. Those ones you don't have to load a library like base, but out of the box, when you want to load it, then to save memory, they don't just you don't load it by default. It does not come as soon as you start it. After you start the machine, you load the library in order to use them. And then for extensibility, that sometimes you load like tidyverse in order to work with data science data frames and data sets. So in this, since R is functional programming, because R supports object and class, and that means that R supports for object-oriented programming. And some of you might not be familiar with object. An object is anything in life can be identified as an object. a person is an object, a human is an object, a teacher is an object, a class is an object, a box is an object, a car is an object, a furniture is an object. But they are identified, categorized as classes. So when you look at a class, it's like a blueprint of the object. For example, if you say class is a human, is a class, now you know that everybody that belongs to a human category or human categorization of human, it is just that class. So the word human, you are just making an abstraction by giving the name a human. So class itself is an abstraction. In object-oriented programming, there are 4 paradigms. One of them is abstraction. Abstraction, and we also call it data hiding, is by giving a human as the class name, you're hiding all the details. So the person does not have to know it. As an example, when you say a class is a car, by knowing that the name of the class is car, you already abstracted. But once you say what kind of car it is a BMW, is a Toyota, or that is the properties, the model name, the name of the car, the color of the car, and then the size of it, and how many tires, and those are all properties of the car. But a car has to have some functionality. So if you look at the functionality of it, then you just say, well, a car could be driven, it could be parked, could be stopped. Those are functionality. In object-oriented programming, a function is called a method. And then a variable, on functional programming is a variable, but not object-oriented programming, you could call it attribute or property. So when you instantiate a class, let's say there's a class called human. Now the superclass is called human, then you could have subclasses, they inherit from their parent class. So there's a concept of inheritance. One of the 4 paradigms is called inheritance. Inheritance meaning that when you define a class called human, then you can say a teacher is a subclass of human. An employee is a subclass of human. A full-time professor is a subclass. So each one of them, they could go a footballer, a soccer player, like Messi is a subclass of human. So, and then once you create that object, you instantiate that class. If the object 1 is, name is Messi, then you know that the property of object 1 is Messi. The type of skill that Messi has, for example, is whether he can dribble or pass or shoot, or that, those are the methods that at certain time, for example, the skill sets or the properties of Messi. But what that skill set, when he performs some tactical skills to apply that skill set, then you say, well, those are methods that he uses at different time. He can get the ball and then make a zigzag kind of dribble, or some kind of jump in with the ball, or cross it, or pass it, or shoot it. All of those are different techniques. So with every object, you have certain attributes. For example, when you look at the teacher as an object, the teacher could teach, could write, could read, could walk, could run, could play soccer, could study, could sleep. All of those are methods for it. But the teacher has a name, then classes that they teach, or the properties of the teacher, like how many classes they teach, what the days they start, all of those are attributes associated with that class. If you consider a class as an object, then that class itself has a location, the name of the building, all of those ones are properties. A class could be created every semester, it could be destroyed, removed after the semester is over. So those are the methods that you apply. So in other words, everything in life is an object. If you look at the vector in our language, when you create a vector of one-dimensional array of 1 to 10, let's say 1 to 10, you have 10 numbers, and we call it on our language the data type is integer. So if you manipulate vector 1 to 10, and then you create a vector 2 to 11 to 20, now you multiply these elements On the vectors, you're doing it element by element. So each element could be multiplied by each other or added or subtracted. So matrix multiplication and vector multiplication are all possible as a result of R supporting vectorization. And vectorization is very big concept in C++, Python, and Python also. I had a lot of videos on NumPy that I showed a lot of the matrix multiplication and also on C++ when I was teaching the class at Pasadena City College. So you're going to enjoy a lot of these videos. First of all, I want to thank you for watching this video. I'm not done yet, but I'm going to just go and demonstrate now the examples and lab activities using R console and R Studio. So, if you haven't subscribed to our channel, please make sure you subscribe to our channel and also make some comments, and then I'll be making more videos for those of you that are in the field of data science or bioinformatics or data mining or data analysis. My job as an enterprise system analyst for 21 years, I have been working for Jet Propulsion Laboratory, NASA, as a senior system admin or database or enterprise system analyst. My job is to make your life easier and then provide you these courses for free so you can come online and learn it. Please be nice, like I am nice to you. Please make sure that when you make a comment, think of my time is also worth your time and your time is worth my time. So just ask something that is going to help you, and I'll do my best to do that. Let me just go to the last part of this video, which is the lab activity for this one. So I'm going to click on R here, which I already installed it. And before I show you this console, I'm going to demonstrate where you download the software to get R language as a console. This is the R console. So when you install it, if you click on this button, R console comes in, and this is your prompt. Prompt shell 1 for R console is this. It tells you that the version is 4.4, and then you can run this function demo, or you can get the license or help the start. It has a lot of nice stuff that you can practice here. At the same time, on the console, you can type in any command. You could do it. And if I just make this screen a little bit bigger, let me go under the preferences, GUI preferences, and then change the font to, let's say, 16 is good enough. And then that is big enough. So right here, you can see I can type in all these help, the license and other ones. I'm not going to do those ones. You can practice it, but for sure, you can type in Q for quit, or just type in the quit. So whenever you log into R, you can just type in quit, and it says, do you want to quit? You can say, yes, I quit. So now if I just open R again here, I can also type in Q here, and I don't have to resize the font. You saw the thing. So no matter how many times you open it, if you just click on this X, also is going to say, do you want to close it? Yeah, you could do that. Same thing with R language, with R Studio. But R Studio has a lot more panes here. So this is your R Studio here. And then if I just click on this window, this is my console window. It comes out here. And notice on the console window, I could type in a quit, or I could just say 2 + 2, and then say 4 times 10. You could just do all kind of computation here. At the same time, if I just want to create a variable, let me just clear my screen first. In order to do a clear screen, you can do Control L, and it will just clear this screen here. And if I just do this screen that is here, is another one for the kind of sources, and you can just get help on information. You can just do this one all the way big, and then you just have one window. But if you want to see this other window, notice that the 4 windows that we have here, each one of them, if you click on, let me just make sure that I get my console. So at this time, I think it is waiting for me to, let's see, it's hanging. It shouldn't hang like that. Okay, so this is the entire computer. No, now it is back. So sorry about that. So whenever you are seeing that one, you can close some of your windows and terminals, making sure that you don't have too many of them here. Since I'm done with this one, I'm going to close that. And then I have a lot of other applications running at the same time, including right here a virtual machine that I'm going to show you also. And I'm recording, so it could sometimes slow down some activity, but at this time I can type in. So if I just say any command, like say print hello world, you could do that one like with R, just doing the print hello world there. But at the same time, I will show you a lot more on that one. So on this screen, you could also get help on a question mark. Let's say you're looking for the function sequence. If you just say, well, what does sequence do? And then you could just type in here and it will give you the sequence commands and then all the examples and everything. But let's just use sequence as an example. I want to show you what you can do just on the console here. So if I just say a sequence of 10 to 50 and increment by 5, I could just get that one saying that generate a vector of 10 to 50. So start with 10, increment by 5, and then all the way to 10 and 50. And same thing, if I just do increment by 10 this time, you could get the lower numbers, 10, 20, 30, 40, and it will stop here. So if I just want to assign that one to a variable, let's say I could say vector1 is equal that sequence of those numbers. Now notice that when I said v1 is equal, I just use the assignment statement, which every programming language, and this one is considered as assignment statement. Or support that one. So if I say v1, now I have that one. Or also, if you just do this one, you can also say that, okay, generate this sequence, but send the output to this v1. This is like almost like redirection. You can see that is the symbol is so v1 and then less than sign that, and then say, for example, sequence of 10, 50, 5, increment by incremented by 10, the same way we did earlier. So v1 is now having the same one. I could also define v1 the other way around. So if I just say like this will just generate that number, but then I say R makes it so simple for you. You could say assign it to v2 here. So notice that sequence of 10 to this, and also I have v2 now here. So you could say send this output of this one this way. That means send it to that variable. This is a variable. So if I say type of v1, you can see it is double. And if I say class of v1, and then I could say it's numeric. But so now those two informations are revealed because we know we created v1 and v2. So if I do the same thing for v2, I just up arrow and then say, give me the type of that one. So this is one way you can just look at that. And if you just say, well, you say data visualization, can I just create some numbers and graph it at the same time? Yeah, it's so simple. So let me just clear my screen here. With R, you don't have to write a for statement, a loop, in order to generate this one. So if you just say, give me a 1 to 10 numbers, and it's there. give me 5 to 55 numbers and start with that one instead. Give me a sequence of 5 to 55 with increment of 10, and then just do that. Sorry, sequence of 5 to 55. It has to be a comma here because sequence takes 3 argument, and then you just do it. When you put a colon, that is not working with this one because a colon is, this is like, you could say for, if I just want to use a for statement. Okay, so when you highlight something, it is not going to release it until you just type in, click somewhere. So now if I say a for statement, I could do something like this with the sequence. I could say for X, and then a for statement syntax is for, and then the condition statement says XN, and then you could say a sequence of 5, 55, 55, 10, let's say. You increment by 10, you just say print X. So notice that the syntax of a for statement says this condition, and that condition is making a function call. And the function takes 3 arguments. So a function on this one, sequence is the name of the function. The first argument is a start, where I start, where I end at 55, and then increment by 10. So print X is going to say 5, and then 15, and so on, all the way to 55. If I want to do the same function in the opposite range, so now you are knowing it, for a statement, you could do that one. So I'm assuming that you want to go from 55 down to 5, and then now you subtract it, minus 10. So now we're going to print from 55 down to 5. And that's how you do that one there. But you don't need a for statement with this. You could just say sequence 55, 5, minus 10, and you're done with it. How simple is that, right? So R is the choice of, the language of choice for data scientists. From all the data scientists, usually they don't have a degree in computer science. Usually they are having some sort of information science or degree, or some kind of engineering degree, some sort of engineering with courses, or some kind of other background, but they know a lot of other tools. They don't know a lot of one tool 100% to start writing everything in a programming language like a developer does. They don't need to. All they need is to say, these are the resources, these are the data set. How am I going to use this Python or R or MATLAB to generate that one? The tool that they use, such as Bash scripting or SQL or let's say Node.js or Python or R or MATLAB, it's just tools. And then this is what these tools are good at. You just have to know how to use them. So my job is to make this your life easier by explaining some of the internal coding that is written in these languages, whether it's a data structure or a for loop or a while loop or something. You just have to look at it differently. So imagine if I just do something like this in this kind of a statement. So easy, right? So now if I say V1 was generated there, now if I say ls command, and now you can see all the storage or variables that I have used. And right here, you can also look at your data set here. Let me just see under, this is the plot of it. And then on this other one, and like right here, all the information I could type in like history, and then just make it a history. And all the commands that I have used are here. Example of those things that are there. And then if I just look at the environment, notice that when I did ls command, ls, it shows me these variables that I have here, right? X uppercase and so if let's say I on the X and lowercase and uppercase, they're both case sensitive. So if I just assign uppercase X to be, let's say I'm going to assign it 20. So notice that I'm going to change those variable. Now if I say ls here, I get those ones, and if I say X uppercase, I'm getting 20, and X lowercase is 5. But this list is not the same one that I have here, because this could be from the previous environment variables. So I could just clear my clear console is to clear this one is like Control L, right? That is going to do this one. For the environment, I think it is CLC maybe? No, that's CLCS for our MATLAB. Let me just, so I'm going to delete each one of these one by saying that remove X. So that will just remove that one. Ls of this one is gonna do that one now. Remove X of lowercase, remove RE. And so let me just clear this one, Control L, and then I'm going to just click on this one, and then let's see if I just, yeah, this is leftover from the previous one. It is not even accessible here. So it is something left over from previous one, maybe global environment. Yeah, in global environment. So package base and then package list. Okay, so you could look at these different information here, and then for each one of them you could see whether you're interested in for the data sets that you could do. But let's just minimize this window and just have this one, and I want to show you some of the packages here as well. But before I do that one, I'm going to do something from the terminal. So in addition to the console here, you could also get help on this one. So if you just say, let's say there's a package here called bet, and you just say, give me information on bet. Bet map is one of them, and then you just say, actually go on the bet and see classes and methods fast memory efficiently. So if you just type in a question mark here, it says this package is not loaded. Since its package is not loaded, it will not give you anything on it yet. In order to install this one, you have to install the package. You can click here on this one to install it, and it says attaching package bed. The following object is masked from package base. So XOR. So let's see if we could do a bet here. Now bet dash package is available, and then it will give you the definition of that one. You could also install the package once you do it. So if I go back to the bet, since its bet is there, I can also detach it. So there's one way you can detach it like this on the command line. But remember, since the package is available, you can attach it or you detach it. So detach package colon bet and unload is true. If you just did not detach it from this one and you attach it, let's say with library, and then I say bet, so I attach it now, and that package is attached here. And if I just want to detach it, I could just say Control V here, and then this one I could type it in, since it is a little bit of longer than just a few things. I could just type in using detach, and then notice that detach takes the argument and saying that what's the package name. So package colon and then bet, and then the unload is equal true. So notice that even a package is an object. This property unload is equal true. When I make it, it just says yeah, unload it, detach it there. So then you do that one. Now the bet is detached. And similarly with all these other ones. So if I just want to see a tidyverse package, like I go here, let me just go on this one. Tidyverse right here. So tidyverse is a very, very, very great list of packages that are available as a collection of packages that are available from a tidyverse.org website. And you can see that this is the collection of packages that they share the same kind of design and philosophy of grammar of data structures or data frames. And then in installing it, it's install dot packages and tidyverse. Usually, you don't have it by default when you install R console or R studio. This is an extended package that you have to do it. With this package, it comes all of these other extended packages, like ggplot is good, reader is there, and then dplyr is there, it's and dire, and then a stringer for string, and a lot of these other cool packages. And then for this website, actually, if you go to the list of packages, and then each package of those ones are explained in detail, like ggplot, what it is, the dplyr. So you're going to be familiar with these packages. Inside of these packages is basically functions and documentations, how to use them and everything. So when you do it for data science, like dplyr, you are seeing that dplyr provides grammar of data manipulation. It's basically for data manipulation. And then this is for data tidy. And then a reader, and then a stringer. All of these ones are for a purpose. You just have to know as a data scientist, why do you want to use one versus the other one? This is for visualization, data visualization and graphic imaging and everything. So if you are looking at this one, there's obviously for the learn, you can come in and look at the book. They have the book. You can order their book from Amazon or just read the PDF and make some donation to them. It's all about what you want to do, whether it's going to help you or not. That's your choice and how you learn it. But everything's for free. You can learn it. I also provide you documentation at MyWebUniversity, my website. So in addition to all these videos that I provide, if you click on this next button here, it opens up this page, and then this page is table of contents on MyWebUniversity. It is my book, and that I wrote it everything for you online. It's a Linux Ubuntu full book, which is 14 chapters. Each book is like another book, because just in here, there's about 32,000 PDF files that you can find, about 62,000 HTML files, thousands of videos. So like online videos, like if you go here and then notice on the first page on MyWebUniversity, this is taking you to my YouTube channel. And then by doing that one, you can just watch all these videos, all of them, 1,300 videos, similar to data science. I'm teaching C, C++, Python, about algorithm, about Boolean logic and DevOps, and then PowerShell, C, C++, Python, Bash scripting, MySQL, Oracle. It's like, you name it, it's there. You could learn a lot of stuff there. But on top of it, if you're just into documentation, you could just come in here and just on each of these, you click. For example, if you're in Red Hat, Rocky, Linux, you could say, well, there's about 11,000 technical documentation, all sorted alphabetically. Whichever one you click, I generate a PDF file for you, and that PDF file is going to be open for you, and you could just look at it there. So let me just go to this one, for example. Let's just open one of them. You don't say why you clicked on it and it didn't open anything. So this is like, in addition, you could see some Google advertisement. You can close those ones, and then let's see if we could just go back to my site and then click on the PDF file, and you could get the PDF file here like this. In addition, if you just say, Wahid, show me what you were showing me with R. So let's say you come in on chapter 12, the dynamic generation of Linux Ubuntu manual pages, because I installed R in my web server. And now I have the whole manual pages for R language, for Go language, for Java, for Python, for all the Linux manual pages for Ubuntu. It's all available in PDF file. Like if you type in bash here, you get the bash.pdf here. So if you assume that you say, what about R? Can I just type in R here? And yes, you can type in R here, and I'll generate the PDF file on the fly for you, and then dynamically. So it does generate it, and then you could learn it. But at the same time, this is one part of the object-oriented programming is code reusability. So if something is already there, you don't want to reinvent the wheel. That meaning that MyWebUniversity already backs the .r.object. This was a URL. I just don't have to. I take you to that one. You just click on it, and then it takes you. Any documentation is on their website. You can just read it from their website. If you say, well, this is nice, can I just come in on this website? And then if they don't have the R documentation, can this one take me to GNU.org? Yes. Can it takes me to our project? So yeah, just remove this there. You can just make it like this, which is the URL that I was telling you. And there's documentation, everything is there. This CRAN is to stand for Comprehensive R Archive Network. It's a list of thousands of 90,000 of basically extendable R packages that you can install. In addition, you can go to the cloud -R. So for each one of them, they provide a mirror of the page, as I showed you on the slideshow on the PowerPoint. But you don't. You could just come in here, and then it will pick up the closest mirror that is available to you. You can get it for Linux, for Mac, and for Windows. For Linux, they have the Debian distribution, Fedora distribution, and Ubuntu distribution. Red Hat, Rocky, and Linux, and CentOS are all Fedora distribution. Ubuntu is Debian distribution. Linux Ubuntu, Linux Mint, and other ones are all Debian distribution. So if you're doing under Mac OS, obviously you have to install the PKG files. Depending on whether you're on M1-3 or a regular Intel Mac, then you just have to select the package. And if you're on Windows, obviously, which I did already, you go there to install the R first time. You can do the base, you click on this one, and then download the R for Windows. You can download it, and I already downloaded and installed it, and that's why I have the R there. In addition, you can type in R Studio, like in some website here. You could say, go to google.com and say R Studio for downloads. And then once you click on here, you're going to just see these pages. So I already downloaded and installed it. R Studio, you can see R Download and Studio for Windows. You can click on it and then just get the post the URL. Let me just make sure that I just click on the same one that I clicked last time. The R project, this is Statistical Computing R project. And I think the R Studio is R Studio IDE, and right here, download R Studio. Here you can do it. So this is posted.co downloads. And then this one also provide you here download R Studio. But notice that R Studio, when you download it, it has the professional, and then professional costed something. But you could do the free version, which is open source GNU general public license. And then you can download that one, which I did that one, and that's free. So you can download the R Studio there. At the same time, if you're on Linux Ubuntu, for example, Let me just show you on Linux Ubuntu. So in order for me to show you on Linux Ubuntu, I already did it last time on this one. So if I say which R, you can see R is installed already, and I can get here. So I can say, let's say, I'm going to say license. If I just do that one, I get all the license information, demo, and then I could do that one. And then I could just go on in here. So right now, I don't have any variables declared. If I say X is equal, let's say, and then I could say an array of 50 to 100. And then just to do that one, X is now generated increment of 1 by default. But if I just say increment of this one by 10, and notice that this not recognized there as this. So that means I have to use as a comma here, and then I could say sequence. So now I could just do the same thing here. X is now those variables. So, but you understand the concept of how you do this one. With this, I'm going to close this one. Say yes, exit out, and then this is Ubuntu OS-release. You can see that I already installed it, and I could do R in there. At the same time, man R, you could see that manual pages was the screen that we just earlier showed you on this information from this. But my program takes this manual pages and translate from HTML to PDF and then show you on the website. So you don't have to be in front of a Linux machine in order to get some help on those documentation. All you do is just come in on the website. Let me just say on the website, MyWebUniversity, one of them was for MyWebUniversity. Let me just go to MyWebUniversity secure page, and you could just come here and then just search for the dynamic, and then just type in R, and just click on here, and now you have the documentation here. From here, you can just go to our website also by clicking that, as I showed you here. So I'm going to show you, like for example, on PDF, not PDF, on Ubuntu, on a virtual machine that I did here. Let me just show you on a virtual machine that I already started here. I'll install it for you. So you can see if you have to install it from fresh, what you do. So now you can see here, I'm on a Linux Ubuntu. So clearing my screen, cat EBC OS-release. And then you can see that I'm on a Linux Ubuntu 22.04. But if I say which R, it is not installed. If I say man R, this one it does not have that manual pages increase. So I cannot just say R and then get to use it. Now, by doing this one, you can see it says that when you do this one, you need to do application package toolkit install and then R-base-core. So it does give you that help on it, but it says please ask administrator to do that one because ID-UN it is not root. So I could just become root and do it, or I could do sudo and then app install R-base-core. So that one, I'm going to provide the password. And then this will just say, do you want to install it? I say, yes, go ahead, install it. Because I provided the sudo access privilege, now I'm getting the R console. After this installation is completed, I will have the R core base core will be installed as a package of R compile interpreter. So while this one is going on, I will just show you this other screen. If you're just doing it not knowing the commands, you could just go here on the www.r-project.org and click on download R. So once it comes out, by default, it's going to just give you a list of mirrors, but you can click on the cloud.r-project.org, and this one is going to, by default, is going to find out the entry to your environments, right? So let me just make this screen a little bit bigger. So now you can see if you click on Ubuntu, which is my system, then you have all the steps that you can do here. In order to get it complete, I would suggest that you could do install R from there rather than doing that one. But notice that sudo update-qq, this one is telling you that you need to do update your system first. Then update apt install -- no install recommends its software properties -common, and then their managers. So there's some additional packages that it requires, and wget on the queue, and then this is the cloud r-project. When you do wget, it's going to need a URL, and so you do that one, and then notice it does the sudo, and then I create the T file, whatever the file is created there, and then -append means this one appends it. So then at the end, once you do that one, then now you do sudo apt, then repository and Debian, and then the name of the package. You could do that one. So if you just say, well, Wahid, you try this one, let's see if this one was successful, because apt install was suggesting it. Ubuntu wouldn't lie to us saying that I'll install it for you. Notice that all the CRAN and Matrix and all the packages, everything that was there, it got created. So if I say which R, it says that R is there. What is R? It tells you that a language for data analysis and graphics. So now I could say a file user bin R. You can see it is a born again shell. It's a bash shell script. So if I say, show me the number of lines that it is there, it's a script, 305 files. If I just want to see the line on it, I could say more or cat -n, and then 5 more here. I could just do line by line, and I see, yeah, it is a bash born again shell, and then shell wrapper for R executable. So this is a little bit too much for you because you might not be a Linux or Unix, and then if I explain each one of the lines, it would be a waste of your time. To respect your time, I'm going to just say, well, this is basically going to load the R interpreter. So basically, if I show you PS here, my bash is my shell here. So if I say ID-UN and get end password Wahid, then you can see that one. I don't have to type in Wahid here. I could say $, and then get it from environment ID-UN. There, it will say the same thing. Notice my echo $sh shell is bin bash. And PS here, it says that bash. And then the first head of -1 of this file that was there, let's see, the file was R. So the first head -1, you can see it's bin bash is called. So if I just say type in R, it's going to take me to the R interpreter. And notice here that is already available for me to do computation and everything. So if I want to use a while statement here, just because I did a for statement, let's just do a while statement here, and then in order to show you. So I'm going to clear screen. Control L is going to clear my screen here. R.version is going to tell me the R version numbers. So system.date date will give me system date, but I have to use it as a function. Sys.date, let's see, I could not find function sys.date. So let me see sys dot, and then notice that when you type in sys dot, and you use tab, it is going to tell you all these parameters that are there. Date is one of them. It's not a function like that, but let's see. Yeah, it is as a function actually. So you can see it's sys.date, and then left parenthesis, right parenthesis. Now I got the system date here. If I get system.info, and I can say class sys.date, and then see what is that one. It tells me it's a date function. But at the same time, if I control L here and then do the same command for let's say info, and then you can see it's a character, a type of character. So that means if I just use this one, I could use it as an object, and I could get that one. I don't have to use it as an object. I can use it like this and say, and just use it as a function. It will return the same information, but each one of them have a different variables and data, like system name is Linux, release is this. So it's like a hash key table, and that is key pair value. The system name is Linux, and then the release is 6.5 and everything. So if I go out of this one into the actual system, I can get this information from Bash also. So let me just add another terminal here. You could say uname-r, and you can see the release name. uname-a is going to give you all the information. cat edcos-release, it's similar to that one. So on this other terminal, you could see that I could then get that information. I'm going to clear my screen. And earlier, I believe I said I could show you, for example, the system. I said that a while statement. That's what I said. So let's get to a while statement. So if I say x is equal 5, like every programming language, you can assign x to have the variable 5 in it. You can do that one. If you say floor of x, you could just say get 5. But let's say x is I'm going to say 5.5 or 5.2. Let's say, and now floor of that one is going to give me that one. If I just say ceiling of this one, ceiling, and then you can get that information. And then if I just make, I could also use absolute value of minus 10. That is going to give me 10, and absolute value of 10 is also going to give me 10. So there's a lot of different ways you can do it. So if I say, let's plot something and say plot of sine of 0, 2 times 5. That would plot the graphic of sine function, and notice how fast, how easy it is for you to do this one. And if I just go back here and I just say dev.off that plot, and just close that plot. So now if I just say this time I'm going to do 8 times the 5, so I could get that information here. At the same time, if I just close it here, I don't have to type dev.off. But let's do this one, and I just want to do a color is equal. Let's say by default, I'm going to have a dark green color. The dark green, and then that would just put the dark green here. If I want the width of the line here, I could say line width is equal maybe 3, so that will be a little bit thicker line width. You could do that. If you just change the color to whatever, let's say some kind of like hash code, you could say red is 55, and then red, green is 0, and blue is 0. So darkish kind of red or red color, it will just do that color for you. And if you want like a really kind of reddish, then you can do that there. So if you want to just get it red, green, blue, let's make it blue. So 0000 and blue is 80. That color. The higher the number, the 255 is the highest, and then you can do FF for 3Fs for generating the white color, and then zeros for black color. So if I just make this 3-digit 0, now my color is going to be black. Why did it not do it? Let me see if the invalid red-green color. So this was not recognized. In order to recognize that one, I have to say color is equal. This is 00, this is 00, and this is 00. So that is all the color that I want. And the 3-digit usually is supported the same way as 6-digit. So each 0 is a replacement for 2, but in this case, it did not recognize it. So that's why I did that one. And if you want a white on white, that's not good. And so the F will not work. But if I do only this one and the green as FF, then you could just see that it's too greenish there. So depending on what you want. If you want it darker, obviously here instead of FF, you just make it 50. So that is darker kind of green. So the option when plotting, you don't have to do this one. Notice here I could do with this and then data visualization. If I just say clear my screen, and then I could say how do I just create some numbers to have a combination of numbers. So you could use the concatenation or combine method, and then a function. So here I could say, let's say I create a vector 1 is equal C combine 10, 30, 20, comma 30, comma 50, comma 100. So these numbers are there. Now V1 is there, type of V1, type of V1, you can see it's a vector and it's double. So if I say what is the class, then you can see the class is a numeric. So at this time, V1 is giving this information. What if I want to get a pie chart of this vector? Then you could say pi and V1, and it will print you a pie chart. So it's really, really nice. So what if you say a V1 times V1? Yeah, vector multiplication. Notice that 10 times 10 is 100, 20 times 20 is 400, and so on. All of the 100 times 100 is 10,000. All of those ones are manipulation. If I say V1 minus V1, element-wise multiplication, subtraction, element-wise division. Each one of them divided by that one is there. So V1 to the power of 2, that would not work. Why? Actually, 100 was there, V1 to the power of it did work. So each element was done. If you do multiplication like V1 multiply by 2, now you see that it is times 2, it is added. If you are not getting the element multiplication, then you have to put a dot to the number, and then it will do it for the multiplication as well. So V1 times V1, you can see that it is there. So V1 module, this is the symbol of module 10. Remainder of 10 is always 0. If I say remainder of 3, it's not 0. For some of them, remainder is different, right? The remainder for the first digit, when it is 3 and there's 1, and then when it is second one, it is V1, depending on V1, the remainder has to be either divisible or this. So you could say, for example, a for statement, you could also say, let me clear the screen. Did I do a while statement? I don't think I did a while statement. Let me do a while statement first. So I could say x is equal 5, and then you say while in the condition of x is less than 50, then what do you want to do with this? So you start a brace here. Make sure you don't close this brace. If you close this brace, it will be infinite loop, because within the loop, you're not incrementing the x. When while a statement, a condition is checked, it is going to go to the loop when this condition is going to be true. If x is less than 50, then it will enter the loop. But if the x is always going to be true and you're not incrementing it to just make it false, then it's going to be a problem. So here you say print x, but then you have to increment that x. Don't close the brace here just after that statement or printing something else there. So like if you say print x plus 2, every time you just add to it, and then at this time, if I close it, it's not gonna just do something. But since x is added, it is not assigned to x. I have to say x plus x is equal x plus 5. So at this time, or plus 3, let's say, you just add the number and then they close it. Now it prints it, and then at some point, every time increment by 3, so it is going to just at some point gets out of the loop, and because 49, and the next time with 3 is 52. Now if I say print x is going to be 50, it already reached 50, so it stops because of the while statement. So Control L here, and then at the same time, if I say x is equal 50, and now I say while, and then the condition x is greater than x is greater than 0, all the way you want to just decrement it. So you want to just say this, and you say brace and say print x, and then x is equal x minus 10. So I want to do it faster, decrement it, and then now it's going to say 50, 40, 30, 20, 10, and then it stops. Now if I print x, it's already 0. So the while statement is going to be your friend also. But a lot of these things, you could do it with like sequence command. So you could say x is equal, start 50 all the way to 0, and then minus 10, and then that would just print those numbers 50 and that. So that's your other friend that you could do. Now I'm going to show you on Windows platform some of the packages that you could attach and detach it to do some data science kind of work as well. Or actually, let's write a function either on this or on this, doesn't matter which one you could do. If you go on the source here, you could just save your function to write it here and save it into a file, and then you could practice it as well here. So, and this is like if I just say here, I'm going to write a function, say, let's say add 2 numbers, right? So I say a function name, I could say add 2. Whatever the number that they provide me, I will just add it there. So then I could say a function x is the argument, and then I could say whenever they do it, I'm just going to say x plus 2. So that is as simple as that one. Now, if I want to call add 2, and if I give it 10, obviously it should return 10, right? Then I could just make a print statement because I did not say print the statement inside my function. I could just call it like this, and then this is called a nested function. So 10 is the argument for add 2. It goes and then replace this value, and this is replacement by value to the variable x, and then x gets added to plus 2, and then the scope of this function has defined the x within this function. So once it gave the argument of 12, this is going to pass on this inside the print statement, it will execute it. In order to run this one, you could just say run here, and it will just give you that output here. So now the add to, if I just say add to, add to, is that a function that is defined? And you can see that it is, let me just make this screen a little bit higher, so we could see it better. And I'm gonna clear my screen here. And then right here, if I just say add 2, and then I could say 5, and then it's going to return 7. So if I just do nested of those ones, I could do that one. And then notice that I could even use a sequence statement within this, and I'd say, okay, go sequence of 10 to 70, increment by add 2 to it. That is 10, and then 12, and then so on, all the way to 70. I could undo that one. But why it didn't work? Let me just see why. And so sequence is this, and then add 2, I just missed a comma here, and then that's how this one should have returned the value. So sequence takes 3 arguments. This is the 1 argument, this one, and the third one was my value that I wanted to add. So if I change this one to add 50, notice that the numbers are really small, 10 and 62, and then I'm done. So make sure that whatever you do on the sequence, it makes sense. You just cannot do a minus that number and then expect some value here, right? So if you do that, when it says wrong sign by argument. And so if you just say minus, and then say 70 here as argument, and then here all the way to 0, and then minus at 5, then it will make sense. So why it did not work? Because that minus is part of the add sequence is not going to take an argument of negative. So in order to do something like that, and then you just have to make sure that the number is properly there. So let me just say, I'm going to so clear screen here. And then the sequence, when you do this one, if I just do this, it would work, right? Obviously, right? So that would just work on it. So if I want to just call my function and then add 2 to it, add 2 is incrementing the number. So that's not going to undo it. Then you have to subtract 2 from it. So like, for example, I could write a function, okay, say sub 2, and then is equal function, and then say function of x, and then return x minus 2. So whatever you are getting it now, sub 2 of 10 obviously is going to give me a 8. And then same thing with if I do sub 2 of 10, and then sub 2 again, and sub 2 of that number, because 8 is returned first. Now I'm doing a nested function call. So I should return 6, and that's what R is smart for. So if I do another nested, like less programming, like with sub 2 of that one, sub 2 of that one, then I should get a 4, right? And then if I just want to add to it, then I say add 2, and then say, since I'm adding 2 to it, 4, and then I get back 6 here. So this is, you understand the object-oriented aspect of it. Every time you just increment it and decrement it by that information. And you can do multiplication and addition and everything with using these function calls with metrics also. So if I say V1 is equal, and then I say 1:10, now V1 is there. Now, if I just want to do V1 times add 2, and that function call, and then I'm just adding 2 here to it, and then you can see that it is multiplied by that number. Because 2 times 2 is 4, and then one, and the other one is 3, as so on. How is it we get the 3? And let's see, V1 was this. So the first numbers, since add 2 becomes 4, 4 times 1 is 4 times 1 is 4, and then 2 times 4 is 8, and then 3 times 4 is 12, and so on, right? Until 4 times 10 is 40. That's how element vectorization happens on the fly. So you're seeing this one. Let's do one more things with tidyverse, and then I'll just end this video after doing this one. So let me just do one more information here. So I'm going to clear my screen here. And I told you that if you want to just load a package, you can see all the list of packages that are here. And notice that if I have already done it in the past, the tidyverse might have already been installed, and because I did it maybe the other day. If I have it installed, I don't have to install it again. But if I go like all these dplyr and all of that one and try to load the tidyverse, and then the tidyverse get loaded, and these ones will be attached there. And then I could just also click here, and then that will attach it. But let's do it from the library. You can use the library function and say tidyverse. So notice the name is there, tidyverse. You can use require or tidyverse. The only difference between require and tidyverse, library is going to give you a status of $0. Zero, meaning that the command successfully loaded the library, and then it will show here it's there. But require, when you do that, tidyverse will actually say tidyverse is loaded. So let's just use the tidyverse with require statement. Require and library or both can be used there. Whether you want to use library and then see it here as package, or use require, it's your choice. Require and library are similar to like import on Python, and then on the Perl language it also has require. And then library is similar to import, and then also require. Like I said, in Perl language is require, and then on Python it's called import, and C and C++ is called include. So you can do a standard IO.h or stream IO, IO stream from C++. And here on our language, you do use a library or require. So let's just do a library. And when you see that when you load the library, a list of the packages that are come with tidyverse, they all get attached. Here, see that this one is attached. The next one, like ggplot, if I go here, ggplot is another ones or attached all. Notice that with this list of packages that are there, you can just go on each one of them and they detach them one by one, like ggplot, and then you could attach them, or click here, or use the detach command, like I showed you earlier, and then gave a list of the packages with that C and then the name of the package. C means concatenate or combine the list of packages there. So you can do detach with all the list of more than one. But if it's only one, you just give the name of the package and you say unload is equal to. You can do that. So this is like all of the packages that are available on this one. In addition to these packages, sometimes you can say data. So whenever you highlight this area, you have to uncheck it so you can type in this one. For some reason, it says that maybe you're trying to get some information. So data set here, you see that data set here, if you just type in this data set and then this colon means the scope resolution. What the scope resolution means is almost, if you're familiar with the directory structure of the file system, it says where to find out the main packages if you go to the directory archive. On the Java programming language, we have some concept of jar files, Java archive files, meaning that a directory structure that is started with .com, you go to the directory of .com and then you go traverse through the list of paths that are there till you find the class file. Similarly, on the Linux and Unix, you have tar-ganzip file, tape archive files. That's also like a path of directory structure. Similarly to a path command on a Windows or Linux, you can see the top directory level where you are and then until to the file system. So a package, normally when you're looking for a package, in order to look at the tidyverse, the tidyverse has these subclasses, sub-packages. And these sub-packages, each one of them, they have their own function calls and their own documentation that you are using in order to just make the function calls with the right parameters and do comparison of head and tail and then all those function calls that you do. But at the same time, you could see this is scope resolution 2 colon. It is used in C#, it is used in C++. This is meaning that once you get to this data set, what is inside this one, if you tab it, all of these lists of them are coming here. As a result, I want to show you one other things, like for example, a data set here is called iris, that is there. So if I do a question mark on a tidyverse, notice that when I do the tidyverse here, you could just get a lot of information with the methods and other ones that are coming here that I told you that if you go to tidyverse.org, each of these packages are there. You could also do tidyverse. Let me make sure that I can see what I'm typing. Tidyverse and then colon, and then notice that as soon as you do, you could get all these dependencies and packages with conflicts, what they are there, and then you could get that one. Or you could say tidyverse $, and if the $, does not give you anything after that one, that means this package does not, it's a package. It's not like a package that you could go there and then it's not a data set, or data set is like data frames that are like iris, for example. If I say, for example, the iris stuff, I type in iris here, and then notice that as soon as I type in iris, it tells me what is iris data. The Fisher or Anderson's data set given by this, all the flowers, the different type of flowers. So if I say at this time Control L and then say iris and then $, you can see the type of species that are there. You can do that $, species. So if I want to say, well, that's good, I can get that information, but can I just clear my screen here and then make this screen bigger, and then I'm just going to look at the plot of iris data. So if I say plot, I could just look at the entire iris here. You could see that it is plotted for me here. If I want to just say change the color to, let's say, dark green, I could put this one, or I could put the hash code. If I'm familiar with the hash code, I could just make it the color, revise it to the color I want. So let's say I go pound let's say I wanted 25 for red and everything else 00, and that would be darkish red, and then I just did it that way. If I just make it the same one for 55 for the red, you could do that one, and you can see the color changes as you do it. So that number is too huge. Sorry, I meant 52 and 00. Yeah, that's good enough. Let's see why the color is not properly set, because oh, I'm missing the pound in front of it. So you have to have the hash code in order to get the right color, right? So if you want it like greenish, obviously you say 00 and then 50 for red, green, blue. So the green is the second column, and then you just get that. At the same time, if you say, well, that's too much data, I want it only for the head of that one, for iris. You could get the head of iris with that color, and then you could just get this. So if you say, what is head of iris, you could get that one and then do this. And then notice that when you do iris itself, you get the data. But if you say glimpse, and then you say the function glimpse takes the argument of the data frame, and you say that give me the data frame, what are the variables or the attributes that are there here. So species is one of them, right? So the type of species that are there. So let me clear a screen and do this glimpse here. You can see when you do a glimpse, it's almost like you do summary here. The summary is another function. You can do this summary. Okay, summary, you can see that is there. So the type of glimpse dot species was one of the variable. So I like to see the data on the species. So I could say, give me a bar chart of, or just give me a plot of it. Doesn't matter. Plot of this one, and then I say iris and $sign species. So then you can select this field, and now you plot it, and you get that one. And you say, just do the same thing with some color, because I don't like the color. Say color is equal, and then green. So you could do that one and then run it, and you get that color that you want. At the same time, if you just say, what about this length information, I could get that one with the length. So Control L, and then you just say this, and instead of this, just get the $, pedal, pedal dot length. So, and then color is equal dark gray. Those colors are usually, you like it. So notice that something went off with the color, because that is taking only 2 arguments. I mean, the keyword is color, not this. So why did it, there were 12 warning, use warning to see them. So if I just want to say warning here, to see the warning, warning messages. So let's see what is the color is this, and then yeah, I'm gonna do now we did it actually, that is the link and the pedal. And so if I just say dev dot off, that color disappears. But if I just want it like that, then it will just do this color on the right side. So the same thing you could do iris dot plot dot link. So and instead of doing this one dot and $sign pedal, let's get some other one, and then maybe the spell dot width, and then just see how that one is there. You can see the data is colored around it. Can I just do that one in a pie chart? pie chart, and let's see. Yeah, you can do that. Look at that pie chart is very kind of like detail here. So that's like my daughter drawing that thing, and she's an artist, so that is something. But let's make it like head of that one. That information, and as I told you that it is listed a statement, so you can do that one and then run this one, and notice that it is that information. So Control L, and then let's say if we just say orange to look like an orange ball. That's like a basketball, huh? And then so you can do a tail of this one. Let's see the tail, what kind of data is going to be presented. That is cool. So you can do a histogram of that one, and then a histogram of it. Let's see if that, yeah, a histogram, you can do that one, and then we did a pie, and you could do a plot of it, and that would be a scatter plot. So there's a lot of data visualization tools that you could do. And then if the orange color is not that clear to you, could say line weight is equal 5, for example. Line width, now it is bigger there. There's a lot of details that you can do with the X label and the Y label, and then main is equal, so you can just give this information something, whatever you want to do with X label and Y label, as well as the information like comma main is equal, and then say, for example, iris $sign is SQL.web. So that is the name of the method, and you can just see that we call it exactly what we wanted to call it. And then if you want to change the X label or Y label, you could do that one. With Y lab, like similar to this. So right here on the this one, you can say comma Y label is equal whatever you want to call it, Y dash label, and then comma X lab is equal for label X dash label. And then you can do that one, and now we change it to Y label and X label. And then the name, if you don't like it like with $sign, obviously you just change the $sign. That's just a string, whatever you want to do it. And even if you type in iris in uppercase, you have a choice of how you want to do it there. SQL, and then oops, I just moved the cursor so fast. Let me just do iris SQL. And then you can do that, and then now iris SQL is there with, and then that. So this is about our programming language. I hope you learned something, you enjoyed it, and then if you're done with this one, obviously you can also write your source code here. I just did it here. If I want to just save the file here, whatever I put here, I can do a save on it, save data, and then reload it next time, or I could just go under file and save it as, and then give it the extension .r and then demo1.r, and then later on, yeah, replace it, and now next time I comment, this function is available when I load it. I can run it and everything. Okay, so I already installed that one. I'm not gonna do the RStudio, but you get the idea that if you have to download the RStudio, it's a Debian packages that I already installed it on this other one. I'm going to show you on this other one that when I did the installation, I went to, sorry, clear screen here. And then on this one, I go to this info directory here, and I created install RStudio. and this is a Debian package, and that is a .debian. And so if I say file RStudio.debian, and then you can see is a Debian binary package, and you use a dpkg-i and then /RStudio, and that would install it. But you have to do a sudo in front of it with a root, and then that will install that one. Then when you're on a graphic interface, you can just run RStudio like I showed you on the other ones, and then you just get it working and run there. Okay, so I hope you enjoyed it, and make sure that you subscribe to our channel, which is MyWebUniversity in English, and also I have MyWebUniversity in 4C for my country fellows and that are studying. Unfortunately, life is really tough for Afghan women and girls. They are not allowed to go to the school as free as boys does. I hope that someday is going to change, or as soon as possible it should be changed. It should have never been disallowed, but sometimes life is tough for unfortunately some of my country fellows for years and everything. So I hope God is going to help them, and inshallah it will be good for the sake of humanity, for all of those ones that are suffering, and suffering will stop, and then everybody have a fair share to go to get educated and get a job and help themselves. And so make sure that you also subscribe if you're from the Afghan or Persian community, whether you're from Afghanistan or Iran or Tajikistan or some 4C spoken person in somewhere in the world, you're welcome to watch these ones, and then just help as much as you can with other ones that are in need of yours. And then also on my website, as I showed you, you can just go and learn the entire Linux and Python and C and C++. And then God bless you all. Take care. I'm going to end it now. Bye.